Hello everyone, good morning. This is Rona Palmer from eMaint Enterprises, and I'd like to thank you all today for joining us for this month's Best Practices webinar. And I'm really pleased to have on the line with me Carl Schultz, who recently joined eMaint as a business development executive. And he'll be presenting today's topic, integrating predictive maintenance, or PdM, into your CMMS program. And a little background on Carl. Carl has over 30 years experience in predictive maintenance and reliability engineering practices with an emphasis on PdM. And Carl's been responsible for everything from full implementation of PdM programs to some of the day-to-day PdM technical activities. And he applies reliability engineering skills to take advantage of the links between your reliability programs and predictive maintenance. So that's a little background on Carl, and thanks a lot for joining us today, Carl.
You're quite welcome, Rona.
And while people are logging in, because I see the numbers going up, can you tell us a little bit? I understand, Carl, that this is a follow-up to your presentation that you did a few months ago that was very popular on a primer or an introduction to PdM. Can you just tell us what today's will be focusing on as opposed to the last session?
Sure. So what I've tried to do here through the webinars is introduce a series, if you will, of proactive maintenance practices. And in our previous session, we introduced PdM tools and the use of the variety of PdM tools that are out there, what their utilization is for, what the advantages of one technology over another might be, and associated aspects with the PdM technology. So this session then will focus on integrating the results of the use of those technologies into a CMMS system.
Great. Okay, well, I think before we get started, I just want to go through a few quick things, some housekeeping items. I do want to let all of our listeners out there know that their phones are muted because we are recording today's session, and we'll share the recordings with you that you can share with your team. So if you do have questions, Carl has agreed to stay at the end of the session and answer all your questions for you, but we just ask that you type them in to the questions feature in the GoToWebinar box. And there will be a brief survey at the end of the session. And again, we just ask that you participate in that survey because that helps us really improve these sessions. So before we get started, I just have a few questions to ask our listeners, a quick instant poll with about 3 questions here. And the first one that we're going to ask is, what is your job function? Would you just mind taking a moment and typing in and letting us know who's on the line with us today? Your answers won't all be anonymous, but it just gives our speakers a good idea of who they're addressing today. Let us know if we have maintenance technicians, if you're a manager or supervisor in the maintenance team, maybe you're a planner scheduler in engineering, or in operations, administration, or some other department. All right, looks like about 80% have voted. So we'll give you just another few seconds here. Thank you for logging in. Okay, let me close the poll and share the results. 13% maintenance techs. About a third of you are maintenance managers or supervisors. 13% planner schedulers. Almost 20% in engineering. 23% in operations or administration. So quite a diverse group today. All right, let's see. One other question, because we will be talking about how to integrate this data with the CMMS. So just let us know who's out there today. Do you currently have a CMMS? And if you do, is it eMaint, or perhaps you utilize a different CMMS? So if you just want to get a few seconds. And again, these are all anonymous. It just helps our speakers know who's on the line. All right, a few more seconds here. Okay, I'm going to close the poll and share the results. Looks like, okay, Carl, about 2/3 of our audience, 68%, use eMaint, about 13% utilize another CMMS, and about 20% don't have a CMMS, but they're interested in the subject matter today about PDMs and how you utilize them with the CMMS. All right, one final question that we're going to ask before I turn things over to Carl is, do you currently have a PdM, which stands for Predictive Maintenance Program, in place? So let us know if number one, no you don't, but you're here to learn more about why you might want to consider integrating PdM into your CMMS. Or maybe number two, not yet, but you do have plans to implement. And number three might be, yes, we have a PdM program, but we're all looking for improvements. And number four, yes, we have a PdM program, but we're satisfied with our current PdM efforts. Okay, so looks like you voted. Let me close this and share the results. And thanks for everybody who participated. About a quarter of you say, nope, we don't have a PdM program, but would like to learn more. About 18% say not yet, but are planning to implement. Almost half say, yes, we have a PdM program, but it can be improved. And about 9% said, yes, we're satisfied with our current PdM efforts. All right, so thanks for participating in the poll. And I'm going to turn the presentation over to Carl. And Carl, you mind going into presentation mode on your screen? And then
I have a little bit of loss of control here, Rona. So if you want to, you've initiated me as the
presenter, yes. And we can see your screen, Carl?
Yes.
But the screen that we see is not in presentation mode. So if you want to go through and launch the slideshow, you should be able to do so.
I am trying to do so. Apologies for the delay here.
No problem.
One moment, please.
There it goes. Okay, thanks. That's perfect, Carl. Thank you.
We're back on air in slide mode. Good. Okay, so to cover today our topics, this is a brief overview of what we'll be covering. We'll go through a very short review of the previous webinar, the PdM tools. We're going to spend a great deal of time in the condition monitoring module, which is really where the CMMS information, or I'm sorry, where the PdM information resides. Talk to a little bit about what's needed for those inspection monitoring results, where in the CMMS you're utilizing it. And then we're going to briefly touch on the importance of data standardization. So these are our topics from a high-level view, the PdM CMMS overview for those that are not currently using a CMMS at all, the condition monitoring module within a CMMS system, where it resides, and the importance of data standardization. So as a quick review here, PdM technologies are typically route-based condition monitoring technologies that are used as analytical tools. They provide identification for various issues that we have with our running assets and or electrical distribution systems, building envelopes, a variety of ways that this technology can be used, as we covered previously. Typically, it's frequency-based. However, it's not PdM, the use of PdM, it's not subject to OEM recommendations, the typical PM plans that we get from an OEM. And there are multiple ways that it can assist with cost reductions or financial gains within a system. And one of the things that we also talked about extensively was the potential that PdM services or PdM technologies have to pay for themselves in a very short period of time. These were the tools that we spent time discussing in our previous session. Vibration analysis itself. These are the typical tools. There are others as well. Infrared imaging, temperature analysis, oil analysis, lubrication, ultrasonic analysis itself, and then motor circuit analysis. So there's also the potential for these to show early successes in a PdM program. Some of them, for instance, ultrasound and infrared, can be fairly, well, let me say infrared or vibration analysis, and I say oil analysis because if you're doing it in-house, can be fairly expensive to implement in-house. But if you're contracting them on an outside service basis, can be relatively inexpensive as well. So there's both ways of looking at PdM tools. But we covered a great deal of that in our previous webinar. So what I would like to do now is move into the actual CMMS itself. So the CMMS system, what is the CMMS? Why use a CMMS? And then a short overview of the various CMMS modules. So what is a CMMS system? CMMS, the acronym literally means Computerized Maintenance Management System. It's a powerful database, and the business processes can include data flow between your CMMS and ERP system, capturing all the associated maintenance-related costs, such as man-hours for payroll, parts costs, inventory, etc., and through this process, even capture data for uptime, throughput, etc. Maintenance workflows then would equate to how your maintenance work actually gets performed, from anywhere from the morning safety meeting to the detailed instructions on how any given task might be performed. And those are the maintenance workflow areas within a CMMS system. Why use a CMMS system? In North America, the average wrench time that we experience with our craft personnel is between 20 and 30%. It's been noted that world class can achieve anywhere from 55 to 60% uptime. So through implementation of CMMS systems, a significant increase in wrench time. It also will assist in moving from a reactive to a proactive culture. And then as well as what we'll discuss more here is moving from PM-based maintenance processes to work processes that involve the use of PdM technology. So planning ahead of time instead of going on OEM manufacturing or OEM manufacturers, what their aspects are. So the traditional view is weighted on PMs, not having PdM feed the work management process. So if we're utilizing PdM technologies in our CMMS to feed this work process, it gives us the capability of significant increases in efficiencies for this wrench time and even work kitting. Work kitting, it seems easy enough, yet how many of our staff are still looking for the problem on the asset that they're looking at? Parts or tools as they begin their day. Imagine the increase in efficiencies if they had everything they needed to work for, they needed in working on a task as a given kit. So within a CMMS system, these are the major components or modules, if you will, within a given CMMS system. A module where you capture your asset data itself, Condition monitoring. This is the area that we'll spend a great deal of time in as we look at how to integrate our PdM results and PdM data. This is your asset health area. Then under the work would be a work order module, a work request module prior to the work actually being turned into a work order. PMs are captured in here. And then you have your maintenance, repair, and operations area or modules within a CMMS. And that's where your parts data resides, purchase orders as well. You have contacts module or employees. Contacts can be anywhere from employees to outside resources. And then within your CMMS system, you have the scheduling, planning, calendar aspects. And of course, the reporting capability within a CMMS by which you can look at the various KPIs and or reports that are all driven from the data that's captured within the CMMS system. So as I said, what we'll do moving forward here for the next 20 to 25 minutes is spend a considerable amount of time looking at the condition monitoring module within a CMMS system. So we'll cover the use of that, some of the forms in there, and then as well various triggers that could be set up in utilizing the results of your PdM data. This is a screenshot of a condition monitoring module itself. Why would you even want to use the condition monitoring module? Again, going back to proactive work processes, becoming less reactive, more proactive. The series that were involved here in beginning with the PdM tools themselves and now moving on to the PdM results within your CMMS system is in fact a proactive maintenance practice series. It also will allow for creating true planning and scheduling capabilities within your CMMS, and it will help to begin the elimination of firefighting within your CMMS system. Now some details within this condition monitoring module. In this particular CMMS system, the screenshot that you see still on the screen here are hyperlinks. The hyperlinks are then active to the various areas that we're looking at within the condition monitoring module. So the monitoring class, this then would be the type of PdM or condition monitoring technology that you're going to apply to a given asset. The monitoring points would be, what are we inspecting, analyzing or testing on that asset? Is it the lubrication content? Is it the vibrational data at a given rotation point? Temperature specific to one leg on a three-phase system. The monitoring points is where you capture within your CMMS what specifically you're looking for on that asset. In this particular screenshot, the assets is a hyperlink to merely get you back to the asset that you are designating the classes and points on. And to continue here, the import readings gives one the capability of importing readings to a form where it varies lists of readings from either a supplier or in-house. It can be automatically imported into the condition monitoring module. Adding readings would be inspector-based or operator-based. So a manual addition of the readings or results from the PdM system. The exception reporting, what this screenshot is really giving you is a workflow of what's taking place within the condition monitoring module. So the exception reporting then is pointing to what the outcome results are. As a result of setting up the monitoring classes, the monitoring points, adding the readings or results, if you will, of the analysis and or inspection, we then have the capability of outputting exception reporting. In other words, what's taking place above or below set points that we can create within the system. And these can be automated workflows, or they can be manually downloaded reports. And then you would also have the capability of actually going into a data analysis area within the CMMS system by which you can manipulate various almost high-level reports, if you will. So rather than capturing them as a report at that particular point in time, go through and analyze what's taking place with your systems, with your assets within the data analysis area. Here is a screenshot of the form for monitoring class setup. So you can see to the right-hand side of the screenshot, let me see if my mouse works here on screen. No, the mouse is not working on screen. So in the far right-hand side of this monitoring class table, if you will, the technology or the class that we've chosen to set up at this particular time is lubrication analysis. Underneath there is a series of questions, Q1 through 15. These fields can be entered as to the types of information that you wish to get from this lube analysis. What type of lubrication are you using? What's the grade? What's the filter type, etc. in here. The advantage then also is that once we go to data analysis and reporting capability, we're also looking at the various columns that can be formulated for output of these results. You could put questions in here as to who took the, or what lab did the analysis, aspects along those lines. So free-form text, if you will, in the variety of questions here. You can also see in this particular case, the email trigger at the bottom of Q15 is set to false. In this particular case, we've chosen not to set this up as an automated response. I've maintained the screenshots in the upper right-hand side so you can see the workflows as we walk through the individual components here. So we've just finished with the monitoring class and a description of that within the CMMS, capturing that PdM data. We'll now move to the actual point setup itself. So continuing with lube analysis, you can see we have our monitoring class as lube analysis, and then the monitoring point is iron. In this particular case, what we're looking for is iron within the lube analysis. So as that report comes back from your lab, whether that's outsourced or in-house, then capturing each one of the individual components that may be contained within that lube analysis area. So this is where we begin to set up the detail of the results we wish to report on, the various aspects of how we want the report to order and label those results. From here then, continuing, we move to monitoring class and points in the asset. What we've done is clicked the hyperlink to the actual asset form itself. And in this particular case, you can see we have down at the bottom of this screenshot monitoring points, and that is set up as the type and monitoring class. In this case, we've now moved to vibration rather than lube analysis. And at the moment, we don't have any upper or lower bounds. If you read across in the chart here under monitoring points, any one of the three lines go over to the columns to the right. You'll see lower bound trigger, upper bound trigger. We have the capability within a CMMS system of setting trigger points if our resulting data and analysis results from PdM technologies fall outside of our preferred norms, whatever those may happen to be. Now what we're looking at actually is there are two separate screens here for ease of both understanding and not creating an overabundance of slides. The top portion is the import readings area, and simply in this particular case we have the capability of selecting a CSV file to import the individual results that might be found from the lube analysis report again, or a vibration analysis report, thermography report, the dB readings, levels, audio levels within ultrasound. The bottom portion then, I might add that the CSV spreadsheet could be something that could be supplied if you're using an outside service. Your supplier or service provider could provide a spreadsheet, .csv spreadsheet of the readings from their results, as well as the other reports that you're familiar with getting. And then the bottom portion of this screen is actually the add readings. So manual input of the ohms from a specific heater in the various barrel zones that we're looking at on a dye heater at this particular point in time. So I just wanted to show you the two varieties of ways that you can get your readings into a CMMS system. Again, the top component being importing those readings, the bottom portion adding them manually. Could be very advantageous if you have an in-house system. Your PdM technician, vibration analyst, if you will, could be entering these readings into that particular area. So we've gone through really a high-level view of setting up the classes, setting up the points, and then importing those readings into the CMMS system. So basically building what we need to then analyze the information that we're looking at. So what's the advantage to this? The advantage then in setting this up is the data analysis itself. Here we're looking at a log of data that's been analyzed from particular assets. So you can see that this is a log grouped by dates. So the 23rd, 423, 424, 425, and the results of discharge temperatures, what the inlet PSI is, differential vacuum, oil pressure, fluid filter, separator, oil levels. All of these numbers are then input into the system, whether it's through import through the CSV or manually input. What I want you to take note of in particular, though, is that in this particular case, what we've done is set up triggers to notify us visually that in the case of 424 and 425 on both assets 100,195 and 100,196, our differential vacuum pressure is out of tolerance. So we are above, in this particular case, our differential pressure threshold that we've set. The CMMS system allows us to be able to set those trigger points, and in this particular case, highlight them with a color of choice that allows us to analyze and see that we're beginning to have issues on these two assets. And you'll notice also, if you will, that on 423, the differential vacuum PSI was at 4. Now, on the 24th, it's at 6. And on the 25th, 195 is at 10, and 196 is at 7. So it's showing us the elevation in issue that we're having with that particular asset. So this is a log view of that data analysis. Moving to the next screen really is just it is an output of the same data, if you will, in a slightly different fashion, so in a readings fashion. Still giving it to us, all of the information by asset number, by date, what the readings are, but just a different view to sort and look through the information that we have on hand. So now we can begin to analyze what's taking place with our assets. In this section here, we're going to spend some time discussing what data we need from our PdM efforts and where it's going to reside, or what we need, why capture these results, and some of the actions from the data and results within this effort that we're putting forward here. So what data is needed, to some extent, will depend on if your PdM efforts are in-house or outsourced PdM efforts. If they're in-house, certainly you can set up standards for whatever data is needed. If it's outsourced, you're going to have to work very closely with your service provider to determine what you need from them specifically. Do you need data in its raw format, or a variety of reports, and then have someone within your organization manually enter those results? You're going to need to determine what measurement points are being used. Those can be route-based and logged, and you may also have the capability of using permanently installed sensors by which that data is automatically being fed to the CMMS system. And then decisions on the various technologies you're capturing from there. So for instance, vibration, you'd be looking at horizontal, vertical, and axial measurement numbers from there. From a lube analysis report, all inputs from that analysis, the complete metallurgical makeup, what the water content is, various aspects of the lube analysis. And then from IR, the actual temperature data itself. And this is where we're talking about the possibility of raw data, or can be the possibility of raw data versus the report format. In a report format, you're going to be given an image or see an image that has a specific temperature associated with an area or a point on there. That could be manually entered. If you have in-house thermal software, you also have the capability of getting the raw pixel data from each one of the images themselves. And then, of course, the other types of data would determine what you're looking for from your motor circuit analysis or ultrasonics. In the case of ultrasonics, you'd be interested in recording the dB levels within your CMMS system. So why are we going to this extent within our CMMS system? There's a significant business value behind what we're driving at here. Again, looking at this as a proactive maintenance process, once the system's been set up to compile the respective data points, we can now begin to evaluate the various business drivers that we're capturing the data for. So some of those KPIs might be, what's the mean time between failure on a given asset that we're monitoring? What's the mean time to repair on that? We can then begin to evaluate what our asset reliability is, what our asset availability is. One of the other advantages you've heard me refer to a couple of times through the presentation here the reports. Typically, if you're outsourcing your predictive maintenance services, frequently what you end up with are significant books, if you will. The reports are produced in paper format or digital format provided to the organization, and many times we have then bookshelves within our offices of various years worth of information and PdM services that have been provided. So what are we doing with those books? Do we create work orders from them? Are we creating work histories as a result of those reports? More often than not, they actually are just sitting on a shelf gathering dust. So by capturing this data in your CMMS system, you're actually beginning to utilize that data in a proactive process, and it has the capability of reducing those book volumes. And of course, business intelligence, and then maintainable parts as well. What your MRO availability is, and it can drive MRO cost reductions. So in my previous webinar in the PdM technologies, I talked about similar aspects in here with regards to what financial savings capability exists. Hopefully we're beginning to see where all of these efforts really begin to tie together in providing not only the financial benefits for our organization, which we know the folks up top always like to drive to the financial benefits of what's taking place within our activities, but also how does it affect our personnel, and does it make life easier for them? So with these business results then, and with the PdM results within your CMMS system, what actually do we have the capability of doing with them? Some of the actions then that can be taken as a result of logging these events certainly are reduction of failure, what those known repairs are. In my previous discussion, I talked about the PdM technologies being able to pinpoint almost for us exactly where a problem within an asset lies. So in the respect of infrared imaging, thermography, being able to see what individual phase, what component, what screw has the issue on it. The same is true of vibrational analysis, to be able to determine which bearings, which race, what the issues within vibration are, whether it's soft foot, whether there's misalignment. What this adds for us is the capability of being able to highlight what those repairs are, so that we're not just sending our craft out in the aspect of, okay, we have an issue out here, we know that it's a vibration because the operator can feel it on his feet when he's walking past it. Let's go find out what the problem is. What we're doing is we're taking and capturing that data through the use of PdM technologies. We're putting that PdM data into our CMMS system. We're analyzing it and being able to determine when and where that work needs to be done. It also allows for some calibrations, and then within production events, look at what the effects are of batch changes or line changes. So if we're changing the type of product that we're running, and let's say it's a dense type of product that we might be mixing in a mixer, for instance. If we affect a batch change in there, capturing this data within the CMMS system allows us to trend what takes place with that batch change, if we're moving to a less dense material or a more dense material, as a for instance. So the importance then of all of this hopefully is beginning to come together as to the proactive maintenance process. I've got about probably another 5 minutes here. What I want to do is highlight then what might be the beginnings of the next in a series here. So we've talked a great deal about the PdM technologies themselves, now implementing that data into your CMMS system. But there are other components within a proactive maintenance work process that affect that. And one of those in particular, and there's been a previous webinar done on this, and they're on this particular topic, and there will be others moving forward. But considering all of our previous discussions, one of the fundamental aspects of a reliability program is data standardization. Whether it's in a taxonomy such as this, as a visual example here, or whatever standards, but standardizing on that data itself, so that when our mechanics go into the CMMS system, they're not floundering around looking for the information that they need on any one given asset. It does affect the business performance. It creates an environment of proactive versus reactive in maintenance and many others, if not all, operational methodologies. Consider this for a moment, how well your inputs and comments from your maintenance folks might improve if they have an understandable and an easy manner in which to locate the assets they're expected to be working and reporting on. And the corporations make large initial investments in the various components that we're talking about within a proactive maintenance process. They make huge investments in the PdM technologies themselves. In some cases, significant investments in CMMS and EAM systems, training of our personnel, etc. Data standardization is a foundational element that will help with the creating a better opportunity to actually realize the investments that have been made in there. And it should form the bedrock of a reliability program. These are just some various components of those foundation elements. Develop a complete and accurate asset list, often referred to in an RE world, reliability engineering world, as your master equipment list. Conduct criticality ranking on your asset list, whether it's through RIME or through a very granular view of the assets, but identifying the most critical assets as candidates for PdM. Many of us have a tendency to get stuck in the weeds when going through a criticality analysis. So suggestion would be to look at what your most critical assets are for your initial work within PdM implementations. It's a good idea to identify your most likely failure modes, identify the most applicable and effective maintenance strategies for each of those failure modes. And those maintenance strategies could be PdM, PM, or even RTF. RTF is an acronym for Run to Failure. Define whether or not you're going to contract or perform your services in-house, and then create routes and set up work orders and begin your monitoring. This is just a sample equipment taxonomy here, so if we're looking at it in the, kind of take this in your mind and put it into the file structure that you would see in Windows Explorer. You have your asset, and then in this particular case we're looking at the rotating asset down to the pump, and the pump being a centrifugal pump, a controlled volume pump, a reciprocating pump, etc. So just an example of a sample data taxonomy here for our assets. I might flip back to this screen for a quick moment, and in looking at the lower screenshot, which I know can be a little difficult to see, we have the same type of a taxonomy that can apply to our inventory as well. So our maintenance, repair, and operations, our MRO inventory, should be standardized as well as the assets. All of this to say, where do you take all of this data and information from here? Ideally, again, and looking at follow-on opportunities and webinars, we're taking all of this data, all of this information, and feeding it into our planning and scheduling process. So the CMMS is a component within your PdM system. Planning and scheduling begins with the use of this CMMS system, and planning and scheduling contributes to overall improvement. It does affect your bottom line, it does improve processes and efficiencies, and it contributes to both the PdM program and the overall success of the reliability program. Just talking about our earlier conversations regarding wrench time, kitting, and other efficiencies. How do you get there? You get there through proper and effective planning and scheduling, which, for all intents and purposes, we've spent about the last 40 to 45 minutes discussing one area within the CMMS, and that's capturing your PdM data and standardizing on that data that you're capturing on. So the reality is, planning and scheduling, we could spend another hour to 2 hours on. That's a wrap on what I had intended upon presenting here. I would open the floor for questions at this particular